Good evening, everyone. I, CA Priya Seth, the Executive Committee member of ICAI J&K branch, welcome you all to the webinar on the contemporary topic of blockchain technology. We have with us two eminent speakers and the chairman of this committee, CA Charanjot Singh Nanda, who will be addressing you in a short while. Before the chairman of the committee starts with his note, I would like to say a few words about him. CA Charanjot Singh Nanda is a Central Council member of the ICAI for the tenure 2022 to 2025. Presently, he chairs three committees of the ICAI, namely Digital Accounting and Assurance Board, Committee on Financial Markets and Investors Protection, and Committee on Information Technology of South Asian Federation of Accountants. He is additionally the Vice Chairman of the Board of Internal Audit and Management Accounting of ICAI. In the past, he has chaired several committees of the ICAI, like the Internal Audit Standards Board, Committee on Internal Audit, Committee for Cooperatives and NPO Sectors, Public Relations Committee, Research Committee, etc. He has also been the chairman of Northern India Regional Council of the ICAI for the term 2002 to 2003. He has contributed as a guest speaker across length and breadth of this country and abroad on areas of professional interest like GST, income tax, overview of SOX, etc. I request the chairman of this committee to please say a few words.
Thanks a lot, Priya. A very good evening, ladies and gentlemen. We are back with yet another exciting program on information technology, which would ultimately ensure that all of us are able to effectively discharge our duties and work as an efficient auditor, not only for our stakeholders or clients, but for the government and regulators as well. Ladies and gentlemen, we have two of our revered speakers today, Madam Anju D. Elvis and Dr. Vinay Kumar Saini, to take into account the rising need of incorporating technologies in the lives of Indian Chartered Accountants. Worldwide, all of us have been working in tandem to ensure that we use technology for the betterment of the services which we provide to our clients. Technology provides us three very important issues. Number one, technology has put to an end the era of sampling. No samples. The entire database is taken into account before you go ahead and give a report. Number two, computers don't have wives. The timeliness of the assignment is fully adhered because the work is done as per the notable achievements and, more importantly, the parameters of the work which has to be delivered. And third and final, there is no risk of errors. It is totally error-free. So, ladies and gentlemen, coming into technology, your board has done so many seminars on blockchains, on artificial intelligence, on chat GPT, on data analytics, on data mining. And largely, I want to tell you that in today's time, there is no value of gold. There is no value of oil. Every value lies with data. But how to use that data effectively, because as auditors or as employees or senior officers of an organization, we are answerable to the audit committee or to the board, as the case may be. So in the instant case, we have to be very clearly be aware of the fact how data analytics is done and how the rightful data is given to the audit committee or the board, as the case may be. So, ladies and gentlemen, in this regard, we are holding so many seminars, and today's seminar would again enlighten and enrich our members to understand how they can effectively use blockchain in conducting the services. So, not speaking much, I would give the dais back to Madam Priya Seth, and I would welcome Madam Anju D. Elvis and Dr. Vinay Kumar Saini and wish this webinar a great success. Thanks a lot.
Thank you, Nanda sir, for your kind words. Taking his words forward, I cannot imagine a world wherein there is absolutely no technology. And data indeed is something which is an invaluable resource for us. With this thought, let me apprise you of how we will go ahead with this session. There will be two speakers for the day, namely Ms. Anju D. Elvis and Mr. Vinay. who will be addressing you in a short while. And I request the members to please post their queries in the Q&A box, which is provided on the screen. And let me take this opportunity to introduce the first speaker of the day, which is Miss Anju D. Elvis. She's a speaker and lecturer from Australia with extensive commercial experience supported by academic qualifications. She is a high performance senior corporate executive, I apologize, with international exposure to global markets and is very well connected to the financial business world. Ms. Anju has held an executive CIMA committee position as chairperson of the Queensland branch CIMA Association and CIMA board member for the Misana region. If I talk about her achievements, she's a global council member of CIMA UK. She's a member of Thought Leadership and Business Ethics Committee of CIMA UK, and she's a member of Ethics and Professional Standards Centre of Excellence, CPA Australia. Welcome, Ms. Anju, and over to you to please take the session forward.
Thanks a lot, Priya, and the rest of the committee, as well as the chairman here. And I'm very grateful and honored that you invited me for this session. And well, we've got a action-packed session today. One, I'm going to give you from my end some case studies. And then we've got another speaker, Dr. Priya, and Vinay, who would then talk about the technicalities related to blockchain as well. So I'm going to start sharing my screen with you guys. You should be able to see my screen now. Am I right, Priya?
Yes, we are able to see it.
Right. So certainly we are in a fantastic era, very exciting. We're talking about the future economy with technology. And this technology today, we are talking about blockchain, Web3, and whatever the technology may be, we as accounting professionals, we need to embed our ethics, governance, and assurance. Those are the key foundation pillars that's needed for whatever technology that we come across. So with that in mind, we'll go to a little bit about me, what do I do, and where I'm based, etc. Priya gave a very comprehensive overview about what I've done, as well as my background. Well, one of the things that I'm also very passionate about is the blockchain topic. And blockchain in my PhD is on blockchain in education, but I'm looking at blockchain related to all the other areas as well. I'm a fellow member of both Chartered Institute of Management Accountants, CIMA, UK, as well as a fellow member of CPA Australia. I would love for all of you to connect with me through this QR code, and that will go directly to my LinkedIn connections. And well, as a global member, global council member of CIMA, we not only constantly advocate our profession across the world, but also very focused on technology as well as ESG aspects. And I'll talk a little bit about that area as well. Well, I cannot forget this role that I play in CPA Australia. I am the chairperson of the Member of Ethics and Professional Standards. That's why, and that's one of the major reasons that we are very focused around ethics today. And we have seen a lot of unethical behavior by some of the big four companies, as well as, well, listed companies as well. So we have to keep this in mind whatever we do. Currently, I'm based in Australia. So it is, I think, about 10 minutes past 11 in the night. And I welcome you from wherever you are. I know some of you have joined from North America, some from the UK, from Europe and India, and maybe even Australia. I welcome you all. And part of my time I spend in the Middle East, predominantly UAE. So if ever we cross our paths, I hope you will come and say hi to me. And in fact, I'm going to be in India in January in Bangalore. And that's where CIMA is holding the council meeting this time. So in January 2024, I will be in Bangalore. If ever you want to reach out to me, please, would be a pleasure. Now, talking about technology, we will look at any technology. We will embrace technology that will increase transparency. I think the chairman spoke about, just before I started the session, he spoke about, well, data is so important. It is more important than gold or oil. Absolutely right. But we need that transparency to create the assurance as well. And this is what this technology brings in. It brings in decentralized ledger technology, and it brings in that single source of truth. We're able to, multiple stakeholders are able to access, of course, as long as we could have a permissioned blockchain or permissionless chain as well. And in this case, we're looking at supply chain. And here, a fantastic example is where IBM offered the blockchain platform and expertise to a number of suppliers, right? And they collaborated with the universities to build this. Now, something I'm really interested in emphasizing here is the collaboration. Some time ago, implementing any technology, we were always focused around, well, this technology, this application is for my company. That's what we all thought across the world. With this new technology, distributed ledger technology, blockchain, we are able to extend that ecosystem. We will work together as partners to make use of the technology. That is, I think, one of the big differences. And here again, I want to give you an example where this particular company from Australia connects the farmers, site operators, traders, brokers, all of them into this platform, to offer this platform to all of them, and so that they are able to leverage this technology and take their business to the next level. Again, you can see that ecosystem coming together and working together very effectively. That's really important here. So AgriDigital is an Australian company. Have a look at them. We also look at enhanced security. So the reason is here. It utilizes advanced cryptography. And it is immutable ledger. This means you're not able to make changes. Now, some of you who are in the technology space will say, well, we are going to get quantum computing and everything is going to change. You know, all this cryptography things will just disappear. True. That is, if our current technology remains as is. And I remember in 2019, when I was researching about the blockchain, etc., one of the other issues that came to the forefront was the cost of energy, the energy consumption this chain utilizes, right? It was exorbitant. And people are saying, my goodness, we're not able to use this because however good it is, we're not able to use it. We cannot scale it up because of the associated cost. But as you know, currently we've got Hedera Hashgraph, who uses almost negative energy, right, when it comes to operating their technology. So you can see that the technology is not remaining static. The underlying technologies are all changing, and they change as we speak. Hence, as the hardware changes, becomes more powerful, so does everything else. Now, let us go to smart contracts. Well, I don't know about you. There have been many contracts. Now, if you look at the normal contracts that we've got, the normal, let's say I'm buying a house. How many contracts we've got there? How many people are there in this whole chain of buying process? We've got conveyancers, we got lawyers, we got buyers, sellers, lawyers from both sides, government bodies, everyone is there. Now, why is this? It's because I can't trust you, you cannot trust me. That's it, very simply. But by using this technology, we're able to take that trust, which we call zero trust, and the trust aspect is taken away, and then we trust in only the technology, not the people. So this smart contract automatically executes upon certain agreed conditions. When the conditions are met, it will get executed. That's what it is, right? It'll reduce, of course, the cost, dependencies. It'll, of course, increase accuracy, etc. Imagine using this in many of our transactions. Now, one of the things, this was done in trade finance. This was done way back in 2018, where HSBC performed the world's first trade finance. Now, I want to kind of reflect a little bit here. I want to pause and reflect. We all know how banks are, isn't it? They're ultra careful. They're ultra careful and they really do not want to take risks. Now, you can see they have gone into this trade finance in 2018 using this technology. So today, many years have passed. They're at a very advanced stage and it's getting better by the day. So this goes to show the importance of this technology and also why we as accountants should get to know about this technology and where we can use them. And another thing is, how can we ask the right questions from your technology partner? So when you work with a technology partner, it is very much a really great partnership. You are in it together. So it's crucial that you have a good partnership with similar values, and we will not just look at that partnership on money alone. We would not go and say, well, this person is the cheapest provider, because there's so many other things that you will need to consider when you are thinking about a partnership with a technology provider. So that's another really important thing that you need to get into your head and say, what questions should I ask my technology provider? And I'm sure the other speaker, Dr. Vinay, will, say some things related to this as well. We, of course, love reconciliations, don't we? And, or not. We've got a lot of automation currently, but by having this technology of blockchain, we're able to improve the efficiencies. And I'll give you more examples on this. We have accelerated the verification process, isn't it? Again, I want to mention what the chairman said. He said, well, sampling has moved away. We will be testing everything in one go. Of course, with AI, robotic process automation, we don't need sampling anymore. We will test all the transactions. We can simplify a lot of financial operations, and we can offer that competitive advantage. And I remember many years ago, I think it was in 2018, a Microsoft CFO who was in UAE, Rekha. She's now in India. She is a CA, a proud CA. And she mentioned at a presentation, again, a CA presentation, how they have improved efficiency through this trade finance. And she mentioned, prior to implementing blockchain, they used to take, nearly a few months. But with this, it reduced to minutes, right, with this technology. So you can see a lot of the big companies are using, not only the big companies, but also now small companies and individuals are using this technology because it is available. But in your case, you need to say, well, why should I learn this? Why and how would it benefit my company? That's important. And you can see that improved efficiency will certainly, it is a big reason why you need to be, you can look at your transactions, your business processes, and ask the question, should we use this technology? And we spoke about the cost reduction. Of course, with improved efficiency comes cost reduction in various ways, right? And a very good example I want to give you is for my PhD, I interviewed quite a number of technology providers, and one is CertifyMe. They said, well, they were able to reduce the cost for education providers by 80% when it came to certificate issuance, then the administration related to it, etc. The same was told to me by EduFeel, and they too are a provider of blockchain, and they're able to issue these, work with the education companies, higher education companies, schools or universities. They're able to work with them and provide this service. Now, this is a game changer. Again, they mentioned that cost reduction of over 80%. Audit trails, again, this becomes, it provides that permanent record. It cannot be altered, and of all transactions, just because of the technology that is being used. That's why. And it always enhances that accountability. Now we go to another area, which is ESG, and it also tackles this. This is a great case study where blueberries are tracked and they are supposed to be organic. So how do we know some product is organic, right? How do we know that it comes from where it tells it comes from? Using the IoT devices, Internet of Things devices, taking the information from the other areas, embedding it into the blockchain. This is how we are able to track the products and see, well, is it what it says, right? So this is a really great case study. Sorry, I'm suffering from a cough, so please forgive me. Regulatory compliances is also another thing, because when we say we are ESG compliant, when we come up with certain statistics, comments, and write up our ESG report, how do we back it up? Now, this is very good. By using this technology, it's easy for us to get that audit trail going. Tax preparation is another one. This is coming to the UAE, and in the UAE, we use a lot of blockchain-related applications. Another favorite is cross-border payment, because it enables a faster, more very effective way of payments. I'll give you an example now. Here it is Santander. They launched the retail payments app in 4 countries in 2021, right? So again, 2021, we are in the end of 2023. They have far advanced. Currently, where I am in Australia, we have quite a number of migrant workers from the Pacific nations. And one of the biggest problems they have is sending money back home, because the cost associated with sending money back home is exorbitant. So they too are looking at a digital wallet and looking at a payment scheme like this, cross-border payment, being able to use digital currencies and get that money to the other side of the world in a very quick time, but also cost efficient. This is another fantastic area. I smile because it untaps a lot of value in assets that are held, kind of waiting to be unlocked, right? So your imagination is what is required to untap this one. There's some great examples happening. I don't have the time to talk about it in detail. In the UK, exactly this, right? Tokenization of assets. So, and how it is being used. So this is a fascinating area. But then again, we have to step back and say, how are we going to reflect this in our balance sheet, in our financial statements, right? So we come back to our fundamentals and look at, well, how do we provide that assurance in an ethical manner? Because we are the custodians of data, and, well, we protect, we are there to protect the public, isn't it? That is what the conceptual framework talks about. So really, even though there's this glitzy, glamorous tokenization of assets, and there's a lot of excitement here, especially in the Middle East, well, we have to have the governance framework and an ethical governance framework in place. And that's where the accountants will play a very strong role. As mentioned, ESG reporting, this is a fantastic tool to utilize for ESG reporting because it will provide undisputable records. And you, as a director and the finance professional reporting to the board, well, you have an obligation. Well, in Australia, this is taken very seriously. So the directors are responsible and they could serve jail sentences. And now, one of the reports I read just recently, we are coming up with this view that accountants have to be responsible for the technology implementations of a company. So the finance professional has to be responsible. So that's an interesting twist because this will change a lot of things. Not only that statement. So when we had to provide some input to this statement, one of the things that we included was, well, you have to almost go to the foundation and start changing the education content, the material itself. So all of you who are well qualified CS may constantly have to revisit and update your skill sets, right? Because technology is changing rapidly. And then we go to an example, how ESG finance is used, right? So then we look at digital assets and sustainability, which is linked to green bonds, green financing, green credits. You can see the world is just, going crazy with this space. And however, you can see with the technology, there's money involved. So there can be a lot of debates. If we thought life was complicated 10 years ago, well, it's going to get more and more complicated with what's happening in the world. So we looked at supply chain. I gave you examples of supply chain and also verifying ethical supply chain practices. This is becoming extremely important. In Australia, we've got an act, which is Modern Slavery Act. In Europe, it's there. In US, certain states is there as well. So you have to prove to the buyers, your customers, you are adhering to this act. So there is a lot of related to supply chain. There's a lot of scrutiny, and best practices are being carried out. And when it comes to the government of Australia, they're very extremely careful of what they purchase because they are the biggest purchaser in Australia, the government of Australia. So they're very conscious about this. I want to talk to you a little bit about, GITEX. Some of you would have been in GITEX, where UAE holds this summit it was in October, every year in October. If you've not gone to one of these events, I would highly recommend. So this was a landmark event because the Israelis came in to UAE. They were the main sponsor. And of course, they're highly, when it comes to digital economy, they're very much up there. And one of the other things we can see in the UAE is they're a small country. So they can do a lot of things. But I'll come to India, and what you guys are doing is phenomenal. So Dubai, they have created the metaverse strategy, and which, the Crown Prince, he was heading this. And what he said is that the future jobs are going to be in this space. It's not going to be in the traditional sectors like oil and gas. So it is going to be in this new economy. Are we ready for that? Right? Not only Dubai and UAE, but a lot of the other countries. So they also came up with these BERA, Virtual Assets Regulation Authority. Again, this is where you can provide your insight and also your advice to the regulatory bodies, and you can influence them because it's really important to do so. One of the other companies that is in UAE is the CEO is a CA, an Indian CA, and they created the digital gold, and they created tokens, right? Because it was a very, very interesting case study, and they saw that many workers were buying gold. Of course, when they go home, we have got quite a number of Southeast Asian workers, and with this method, even if they have 10 rupees, they're able to buy gold through a token, which was not possible before. And you can use it in an app format. And the co-founder and the CEO is Naveen D'Souza. You can link up with him in LinkedIn. He's a fantastic speaker, and he will talk to you more about his application and what they are doing. And again, one of the biggest things here is how they have this company provided that assurance. They provided the governance and the trust because they have surrounded themselves with the government bodies and external parties to safeguard the actual gold that's held. So the physical gold bars are backed by a token coin. Their vision is this year, I guess, no, early next year, they're issuing a credit card type of like a debit card where it's backed by the gold that you have got, right? Quite interesting. So this is a statement that I really like. Future is already here. It's just not very evenly distributed. And again, this is a very interesting research that was done by Swinburne and CPA Australia. And they talk about how we could use NFTs to improve security, transparency, sharing of sustainability data. So you can see this is all researched back content material. It is not coming from a sales pitch, right? So you can go have a look at it as well. So we in South Australia, I'm based currently in Adelaide, South Australia. We are doing a lot of activities related to blockchain, Web3, and technology as well. So the new economy, you can see central bank digital currencies are popping up everywhere. There's a lot of research that is being done as well. And Australia is heavily gone into that research space. They have created a white paper, and there's a lot of discussion around it, how we could use these CBDCs, how we could use stable coins, etc. How will it impact the public, the positives, negatives, who are the actors involved. So this is another area we can really contribute to the discussion And to contribute to the discussion, well, we need to have some knowledge about it, isn't it? But I must say, we are not moving away from the fundamental principles. That is the biggest thing that I have to say. So, development of blockchain-based accreditation governance framework for education sector. Now, this is a big word, but this is my thesis, right? And doing this, I came across something very unique, what India is doing. I'm very proud to say that I'm an advisory director for a company called IDS. They've got it's a US-based company with all their blockchain developers based in India. And they built the first metaverse in education. They built the first metaverse in the world for the education space, and that is in India. And looking at how the Indian education system is changing and what it has already changed. So for me, it is fascinating to see where it has taken, where it has started, where did we start and where it has gone to, and the change that is expected as well. So that is really fascinating. And here again, I want to emphasize the importance of ethics, governance, education, health, digital currency, and the data. So there is a big project happening about health data in Australia. That's a huge thing. Something, again, I'm sure India will be going far ahead with that as well. And with that, I come to the end of my presentation, and I want to hand over to Dr. Vinay to take over from me. Thank you.
Thank you, Ms. Anju, for the wonderful deliberation. There are a few questions which I have in hand. Would you like to take them right now?
Yes, yeah, that's it.
All right. CA Hitesh wants to know that how do we record the blockchain transactions and what evidences do auditors look into?
Yeah, that's, I'm going to leave it to Vinay to talk about it, because he will come up with that technical angle, because that's really important to talk about the technical aspect, because we're going into the crux of the characteristic of the blockchain, right? That's what it is. Yeah, the next one.
I believe the other questions are also technical, so I will wait for the second session to end.
Yes. Sorry. Okay. Thank you very much. And I'll switch off. It's pretty late here. And good day to you all, and hope you have a wonderful session. Thank you.
Thank you so much for enlightening us with your knowledge of the useful information on blockchain. And I wish you very well, and good day to you as well. Bye-bye. So dear members, we have the second session starting in a while. It will be taken up by Dr. Vinay Kumar Saini. I want to take this opportunity to introduce him to all of you. He has more than 18 years of experience in software development, information security, training, research, and consultancy. He is an MTech in information technology and PhD in computer science and engineering, blockchain. He has qualified CISA and is a certified faculty with Wipro and Infosys. He has published many research papers in journals and proceedings of international and national conferences. He has delivered many guest lectures on various topics related to information technology, risk management, IT security, and IS auditing related concepts in leading institutions like CA Sri Lanka, IEI, ICAI, TIPS, and so on and so forth. Welcome, Dr. Vinay, and over to you to take the session forward.
Hello, Priya. Good evening. Good evening, everyone. I think, thank you for your introduction. I think we can take a break of 5 to 10 minutes maybe. I need to get to my machine and then I can start with all this technical things and everything. All right. So, like whatever queries are there, and perhaps the technical aspects on how blockchain works, it's quite interesting and exciting because there are so many opportunities. As a consultant, as an auditor, on uh, assuring whether the blockchain is going to deliver the benefits and what are the risks. So there are a lot of exciting things which are lined up. We will be continuing with all those things. I think we can take a bit of break here. I was supposed to take the charge at 7:30, I guess, but I think it's a little early. No problem. I think we'll continue with all these technical aspects in a short while. I hope that won't be a problem. Let's take a break of 5 to 10 minutes.
No issues, no issues. We can wait till then. Till then, I request the members to please keep posting the queries in the Q&A
Yeah,
box, which is right
yeah.
on your.
So my discussion would be totally technical, like how blockchain work, how the truth is preserved in the blockchain, and how we can have use cases around, and what is feasible, what is not. So we will talk about all those things, right?
All right. We
Yeah, yeah.
have.
Please take a note of all the queries. Thank you. Thank you, Priya.
Yeah, all right. Thank you. Dr. Vinay, can you hear me?
Just a second. I'm just switching on my system.
All right.
Thank you.
Dear members, we are beginning the session in just about a minute or so.
Good evening, Priya.
Good evening, Dr. Vinay. I am able to hear the echo.
Just a second.
Dear members, really heartfelt apologies for the delay and thank you for your patience. Over to you, Dr. Vinay. I believe it's perfect now.
Yeah, I think we can continue now.
Yes, please go ahead.
Yeah, good evening, everyone. Welcome you back to this session. Sincere apologies for a bit of a break in between because of a small matter that I was traveling. Now I'm back at my place. So yes, I think it's a great initiative by DAB, ICAI, and rightly mentioned, data is the most valuable asset. And perhaps, yes, we must have adequate provisions around data to be stored, to be processed, to be transferred in a manner that delivers assurance, business objectives, and yes, it ensures stakeholders' concern, right? And these are the primary reasons why we as a community, we as consultant, we as auditors, we as collaborators are gathered here for a purpose that let's understand, let's decode blockchain and understand how it works and how we as a contributor can deliver our role in assuring the practices around blockchain. I think Anjuman mentioned a lot of applications at global front, right? How blockchain is being adopted all over the world for various use cases, right? And yes, it's really a technology with a lot of potential, right? But the way it was introduced to us was a little surprise, right? Like many times I observed that people, when you want to talk to people about blockchain, the first point is like, what is Bitcoin? How it works? Should I invest in this or not? What is the future? And what about cryptocurrency? So these are the general perceptions that people carry about blockchain. But yes, we need to understand that blockchain is a technology, right? It's a technology which is customizable. So I'm pointing it out. It's a customizable technology. So you need to understand what exactly you want to achieve. So you can build cryptocurrencies, you can build NFTs tokens mentioned by Anju ma'am. What else? You can have academics around like academics, trade finance, supply chain. There's so many applications around blockchain. So in today's discussion with me, we will try to discuss all these things, and I'll take up your questions, and I'll show you on how it works and how it is delivering assurance that it is immutable. It can ensure smooth communication where we are not relying on trust on the people, right? So as mentioned by Anju ma'am, the trust would be embedded in the technology, and we are not bothered about the trust on human beings or the people. That's one element where you can have unethical practices, you can have frauds, and many other things where you can have tampering of data and many unethical practices. So without any delay further, so let's move on to the discussion, right? I'll quickly tell you about how it works, right? First, we'll try to understand the fundamentals on how fundamentally technology, this blockchain technology works, and why it is having such a positive impact. Like it can be tamper-proof technology, it can take care of your security concerns, it can make your process faster, and it can deliver all compliance and regulatory related issues, right? So before we move on, I think it's important to understand there are a lot of technical aspects, right? So I'll explain one by one all these things, but let's understand from non-technical perspective. So I hope this slide is visible to all of you. If you see this slide, it's like there are a bunch of kids who are playing football, right? So let me tell you one thing. The biggest challenge here is it's hard to identify whether like there are two teams or like you cannot really identify which guy belongs to which team, right? So, but ideally, let me tell you, we all have experienced this kind of play in our childhood, right? So ideally speaking, there are two teams, right? So there are two teams, though it's hard to distinguish. Second thing, there is no referee, right? There is no referee. There are no regulators around, right? There are no big agencies. There are no sponsors. Nobody is out there. But the game that is happening there is a fair game, right? Everybody who's playing this game understand the rules, right? Everybody has the same understanding of the game, right? So let's say team A is playing against team B, and let's say a player from team A commits a foul, right? It's a handball in football, right? So let's say it's a handball. And the moment anybody observes from team B, and he raised a claim that it's a handball, and the moment he raised the claim, somebody approves it, right? Somebody around the team, or maybe it may be a representative from team A or team B, doesn't matter. The moment there is assurance or support, immediately it becomes a fact. So it's a truth now. The foul has been committed. So whatever is the next step, like there will be a free kick or whatever is the provision, would be allocated to the team B. Now the game goes on. So what we learn right now is that blockchain is basically a network of players, or we can say machines, right? They're playing a game, right? Like they are playing, like in this example I mentioned, they're playing football. So let's say it's about cryptocurrency. So they are playing a game of transferring cryptocurrency from one person to another person. Okay. So the other aspect is, let's say after some time of play, the score is like team A has 2 goals and team B is 0, right? And if somebody comes out and say, oh no, the score is 2-1, do you think anybody will accept it? No, everybody is playing, everybody is having the same understanding, same visibility, same transparency about the application, about the game, and everybody knows it's 2-0. So everybody's ledger, we call it as ledger. So every machine is having a ledger. Score says 2-0. Every ledger says 2-0. If somebody comes and say it's not 2-0, it is 2-1, the claim would be rejected. It's like somebody's trying to tamper the data and claiming that this is the right and valid data. So it would be outrightly rejected, right? So this is how you can see how the motivation about building such technology came into picture. So we want to have a distributed system, right, where we don't want anybody centrally to control it, right? And still we want complete transparency, complete security, and immutability. Nobody should be able to change it, right? So if you want to achieve all these things, if you try to understand this game in the picture, you will identify there are certain things we need to achieve, right? One thing is, if somebody's trying to make a foul, like wrong claim that the score is 2-1, we must have some programmatical capability that the claim should be rejected. Okay. And the other thing, every machine, let's say there are 100 machines, 1,000 machines, they all should have same rules, same protocols, right? All the machines should have the same software, right? Only then they can participate, they can contribute, and they can work together. Whenever there is an event or a transaction that gets executed, verified as per the rules of the game, it should be recorded and should be transmitted to everybody. So everybody should update their ledger that this is the score, this is the final status of the ledger. And if somebody else comes into picture and say, or wants to change the record and say, no, score is 2-1, so it would be rejected because it's not matching with the majority, right? So in a way, we can say that blockchain gets the motivation from what he calls democracy, where majority wins, right? So whatever majority will say will be the truth, right? So now the fundamental motivation behind blockchain is, let's take a transaction, right, and convert it into an element of truth and put it in the technology or a ledger or a system in what you call digital format. And it would be stored in a manner which cannot be reconverted. Or let's say there's a transaction from player X, let's say person X to person Y of say 10 Bitcoins. So nobody should be able to see who has transferred this data or transaction like funds to somebody else, to whom. And you cannot even see how much transaction is taking place, right? So it should be secure from getting accessed or misused by somebody else, right? So all these are some of the exciting features which are the building blocks of the blockchain applications. Now, I'll quickly give you a bit of idea about how all this works, right? So that you can understand from the perspective of technology, that how technological components are connecting together to provide us a tamper-proof system, right? And nobody can alter that data, right? So I'll quickly take you through all these technical terms and we will discuss this one by one, right? And I'll give you a detailed understanding on how all this works, right? So let me just quickly give you a quick introduction about these terms so that we can then get into the more detailed things, right? So these are the components, right? These are the technical fundamental components which are working in the background to make blockchain a secure technology where it can really run your applications in a manner which are secure, transparent, and little faster as compared to normal scenarios. Now, cryptographic hash function, it's basically a mathematical function which convert your data into hash. Now, you'd be thinking that this is little technical. So I'll take a quick demo part as well so that you understand the technology by experiencing it, how it works, right? So I'll open a website where I'll show you what is the concept of this hash function and what makes this blockchain system immutable, right? Just a second. Let me just open that URL and I'll show you about how this whole thing works. So it's a quick interface, online interface where I can show you about these aspects. So it's a website, right? andresbronworth.com blockchain demo. You can search it on web as well, and you can try alongside me as well. So what is hashing? Hashing, or perhaps cryptographic hash function, is a mathematical function which converts any data into some code. So let's say I have a transaction or any data, let's say M1 sending some, say, 10 coins to M2, right? Let's say this is a piece of data that is fundamentally a transaction. So when I'm saying data, it could be anything, right? It could be like Anjuman mentioned about blockchain in education. So like it could be a degree data, certificate, mark sheet, credentials, or it could be supply chain data. She mentioned about a use case where you can trace the origin of food products, or like you can have blockchain applications for addressing this duplicacy, right? Popular and expensive brands face this risk of duplicate products in the market. So all these issues can be addressed by this technology, blockchain. So I'll quickly tell you that data could be anything. It could be a product data, it could be a mark sheet data, or it could be like transaction data, like somebody sending some money to somebody. So anything that carries value and you can represent it as a transaction or transactional data can be considered data here, right? Now, this data would be converted into some code, okay? Some code, we call it as cryptographic hash code, okay? So now what happens is, let's say this is a transaction data and there is a code called ECD, starts from ECD and ends with 80B, right? If somebody is trying alongside me, you will get the same code, right? To make it a little simpler, I'll simply write hello in small capital letters. So it starts with 2CF and ends with 824. So if you try on your system on the same URL, andresbronworth.com, it will be the same code. It means you can convert any piece of data to a code, small summary. Now the beauty is, every time you want to validate the data, whether the data is correct or not, the way is that you have this code with you. So anybody wants to verify whether the data that they have received is correct or not, just try to convert that data again into code. And if that code matches to your code that you carry, the proof of truth, then it means the correct data is correct. So fundamentally, the logic behind blockchain is, whatever transactions are happening, convert that transactions into truth, a hash value, which is immutable, right? Well, let me tell you, every time you convert this hello word, it will give you the same hash code, right? One thing. Second thing, you cannot convert this hash code into the data. Means you cannot get hello from this hash code. So that's another interesting property, attribute of this hashing. So it's irreversible. Got it? So first thing was cryptographic hash. So idea is, whatever transaction is taking place, convert that transaction into hash code, which is immutable. And it will be a piece of truth which will be recorded in the blockchain. And then blockchain will keep on maintaining these truths. So whenever we want to verify and validate, we can check whether the data or transaction is correct or not. And nobody can tamper this, because it's the truth that we are storing in the blockchain, not the transactional data. Transactional data may reside in some other database, again secured. There are many strategies on how you want to build an efficient blockchain for your requirements. I mentioned earlier, it is a customizable technology. It means you can configure, you can design the elements, the blocks, the components of the blockchain as per your requirement. And you might be wondering, what are those requirements? It could be performance, it could be security, it could be compliance, it could be business objectives, and like scalability, how much you want to scale. There are so many elements around blockchain applications which you need to decide on, right? So there are exciting opportunities. There's a lot of opportunities which you can explore, right? Now, moving on further, we got the understanding of what is hash. So hash is the element of truth based on the transactional data. We convert it into a summary, small summary, which cannot be read. Like, you cannot convert that summary into your data, right? It could be a huge data converted into a small summary. Now, the other thing, this block
is basically collection of these transactions. So a data represents a transaction and a block represents collection of transactions, a group of transactions. Let's say there are 10, 15, 100 transactions. You convert them into code and they are getting converted into a single code. So that we represent as a block. So block is a container which has transactional hash codes, summaries, right, as a element of truth for those transactions. And the whole block, single block, is represented as a single hash. So if you put anything like some data, it will convert that data or transactions into a single hash code. But then you can define a validation here. Now you can see that this block color changed to a pinkish or reddish color. That's an indication that it's an invalid block. Why it is invalid? Because there is a validation applied here that the block will only be accepted if you will solve a mathematical problem. Now you would say, why we need a mathematical problem to be solved here? Because you know that when the transaction, the whole process would be working. Let's say somebody raises a transaction. Now this transaction needs to be validated first, whether it follows all the rules. Anju ma'am mentioned about smart contract. So does it agrees to all the rules of the parties, like multiple parties which are collaborating? Does it follow all the rules, business rules, conditions, compliances, right? That thing. The second thing, we want to ensure only the genuine people who are authorized, right? Or perhaps the people who has adequate, authentication or adequate ownership, or there can be many factors like let's put a mathematical challenge. The person who will solve the mathematical challenge, only that person would be allowed to verify the transaction. So here the first step of validation and verification is you convert the data into hash code, but that hash code should match certain criteria. So here the condition is the hash code should start with 4 zeros. So if I click on this mine button, what will happen is I will try to solve this mathematical challenge. I will check for so on. I'll try to find a number which will get connected to my data and it give me a hash code which has 4 zeros in the starting. Now you would ask, sir, why this 4-0 concept is there and why only 4 zeros? So let me quickly reiterate. It's a mathematical challenge which we have posted, right, for selecting a person who will verify and validate the transactions. Okay, now you see the game when the boys were playing there. Okay, you would have seen whenever you are playing a football game in your childhood, let's say somebody has committed a foul, right? And somebody is saying, oh, it's a foul. And now there'll be quick arguments, right? Somebody is objecting, somebody is supporting. But there is one guy, if that person says, okay, I go with this guy and he's good to go and it's a foul, then everybody start accepting all of a sudden. You may say that the guy is a powerful guy, influential guy, but let me tell you, in blockchain, he's the guy who has solved the mathematical challenge, right? That's why everybody is listening to him, right? So means the node, the computer in the blockchain network who will solve the mathematical challenge will get a chance to verify and validate the transaction. Because just imagine there are 1,000 nodes. If everybody start verifying and validating the transaction, it would be redundant activity. And it would be a waste of resources, right? So what we need is one should be selected to verify, validate the transaction against all the rules in the smart contract, right? And once that has been verified, then the block would be mined. Means the person who has been selected will approve that the transaction has been processed. This is the summary code, like the truth. And everybody, please update your ledgers that this is the status of our blockchain, right? This gives you a truth that these many transactions has taken place, and this is the truth which you have to preserve in everybody's computer. So like if there are 100 players in the blockchain network, every computer will have the same hardware, same software, and same ledger. Ledger means these blocks are connected to each other, right? And I'll show you in the next slide how they're connected. So you understand hash, you understand the block. Now you'll see block 1 is connected to block 2, is connected to block 3, how they're connected, there's a element called previous hash. Okay. So means block 2 will be having the hash of block 1 as a linking element. So if you want to see which one is block 1, you can easily reach out to block 1 by just reading the hash, previous hash element in block 2, right? So this is how they are connected. It's like a chain through which they are connected, and chain represents the address of the previous block. And the first block which is there will be connected to nobody, right? It's the starting block, so it will be not connected to anything behind it, right? So this is how it goes. Now just see what happens now. Let's say you have a scenario like this. So you want to keep on doing transactions. So whenever there'll be transaction, you will see there will be more and more blocks coming up. Let's say somebody is trying to manipulate or tamper. Let's say that person says, okay, I got an information that block 5 has been mined, and I got a notification that everybody has to update their block 5. But let me tell you, whatever the block 5 is saying, it's not the valid block. This block 5 with hello is the valid one. If you see, the valid one is this one without any data, right? Even no data is a data, right? No data is also a data, right? You can convert it into data hash. So let's say there's a malicious player. He's also the member of the blockchain. It may happen, right? Malicious player, member of the blockchain, wants to tamper the ledger. The ledger says there are 5 blocks. So he says and comes and says, no, this is the 5th block. And my claim is this is the 5th block. And now if he wants this block to be connected to the blockchain, he has to mine this block with a changed data. Now, he has to solve this mathematical problem. It will take some time. Once he solves this mathematical problem, he is eligible to post a fraudulent transaction. Okay, he is eligible to post a fraudulent transaction. But let's say this is just the case with the last block, the immediate last block. Let's say he's trying to change some data in some previous block, right? So what will happen? You'll see, for this fraudulent thing to be implemented or claiming that this is the valid, the challenge is even bigger now. He has to mine 3 blocks now, right? Because the chain needs to be in sync with the basic validation rules. So the challenge is bigger if you are trying to tamper the transactions way back in the blockchain, okay? Now it means that if you have a blockchain, if there is only one node, then if that node wants to play malicious and wants to tamper the data, he has to solve mathematical challenges. Only then he can claim. But if we make it as a distributed, people might be wondering why we have so many nodes in the blockchain, why we are having so many machines. The reason is, if let's say somebody is trying to tamper the blockchain ledger owned by him, like, because if you are a player in the blockchain, you have the ledger, right? So let's say you are tampering this one in your ledger, right? And claiming by mining, claiming that this is a valid. This blockchain that you mined, the ledger you carry, will not match with the ledgers with the people. Other people who are having the ledgers will have the different ledger, and majority of the ledgers will not match with you. So eventually you will be discarded. So this is the whole concept, right? So let's say there's a simple application where you are issuing a certificate or a registry, property registry. So it may appear a interactive application, like you are applying for a credit card application, or you're opening an account, you are transferring your fund from one account to another account. But in the back end, what is happening is your transaction is received by a software where it's a big network. There are thousands of machines, thousands of computers. One is selected who is solving the problem first, and then he verifies, approves, and everybody updates their ledger based on the truth shared by that person or that machine. The point is, everybody on that network has the same hardware, same software, but not hardware, same software, same smart contract, same rules, same provisions, same cryptographic standards, everything same, right? So this is the fundamental thing. You can take it to the next level. Like this was just a fundamental thing. Now you can see that block can have transactions, right? So it could be banking transactions. It could be transactions of products or time stamping. There can be so many things. Let's say there is a company who is manufacturing, say, branded shoes. Okay, let's say in US or maybe some other country, and they have a risk of duplicate products in the market. So what they will do is they will embed during their manufacturing, right? During the manufacturing, they will embed the RFID in the shoe. Okay. So now there's no way you can get that RFID out of that shoe. Why? Because you have to tamper the shoe, and the shoe will be of no use after that. Okay. So you manufactured a shoe, you embedded a RFID in that. Now what all you need is a application, blockchain application. They will scan this shoe with RFID, and with this RFID, there will be a timestamp and a transaction that packaging happens. It goes to warehouse, right? And in the warehouse, there is a scanner. Everything is automatic. There is no human intervention. So the scanner scans, okay, warehouse, the product has been received, and it reached the warehouse on this date, this time. So when from warehouse it goes to shipping to cross country, and then it goes to warehouse in another country, then retail house, everywhere it's getting scanned. So when as a customer you go to a retail shop and get this product, and when you scan that RF product or RFID or a barcode, it will give you the detailed history of that shoe, the journey of the shoe, when it was manufactured, when it was packed, where all it has. That shoe, again, a transaction will get into the blockchain that this product has been sold. Now, let's say if somebody wants to create duplicate copies, what will happen? They may have to copy the RFID also, right? They will, let's say they created the same RFID and copied the RFID and then put it in the shoes, right? Now it means for the same RFID, they'll create maybe 1,000 copies or many copies. Now, let's say a customer comes to purchase a tampered shoe. Okay, now the moment they will scan, it will show that this shoe has been sold to somebody on that date, right? So this is how you can track and you can maintain the, what do you say, originality, authenticity, and origin and traceability of the product and the life cycle of the product, like maybe food products, fruits, whatever, and maybe this branded products where you want to eliminate this duplicacy and other things. So I hope you got a fair bit of idea about how in the back end this concept of cryptographic hash and the other aspects like distributed, like it's not one computer, there are more than one computers in the background, and they are maintaining the same ledger, right? Same copy of ledger, so that you can achieve that capability, right? The capability of security and immutability. And there are many more elements. Let me quickly jump into that. It's a decentralized network. It means there is no one machine. There's a network of machines with the same softwares. Consensus mechanism. I told you that all the machine will follow the same, uniformity in terms of processing of validation and verification. I told you that everybody agrees that, okay, if a person solves this mathematical challenge, he is eligible to verify and validate the data or the transaction. Everybody will accept that. So means we need to have that uniform standardized mechanism defined, which will be followed by everybody in the blockchain network, right? So it's like how the candidate would be selected who will get the chance to verify and validate the transaction. And verification, validation would be done according to standard rules, terms, and conditions mentioned in smart contract. And smart contracts are the provisions agreed by the parties who are part of this whole process, right? Blockchain process. Like if you're talking about this property registration application, then you have registrar, then you have buyer, seller, lawyers, bank. All these parties are the players. Okay. I mentioned about the blocks. Blocks are nothing but a collection of transactions, right? A block can have a group of transactions and they would be converted into hash, summary code, which will be serving the purpose of a truth about that transaction. Like this transaction has been verified. Distributed ledger, yeah, it's a ledger which is distributed. Like everybody has the copy of the same ledger, so you don't need the reconciliation and other things. It's just the ledger you maintain, and it'll be a series of hash codes, nothing else, right? So it's a collection of truth. Immutability, you cannot tamper it, right? It's not possible. It's not feasible. Technically, it's not feasible. It's not because it's like a fundamental principle of security. Let's say if you want to break a blockchain and get a value of say $100 million, you may have to spend $200 million of resources to try and attempt to crack it, because your claim will only be accepted if more than 50% of the machine agrees to your claim. It means you have to hack more than 50% of the machines and put the same claim at the same time. If they have the same ledger, only then they will approve it, right? So it means you have to hack 50%, more than 50%, right? 51% of the machines. And if they have the same truth that you are claiming is the new truth, then only your truth would be accepted, right? And still, you can create more complex logic that may defy this also. Along with 51%, you can define certain key nodes also, like the person who has specific identity should also agree, right? There's a saying like, okay, you approved in the parliament, okay, then there is a head of the state who has to sign it, only then it will. So means you can create complex protocols. But then you would say, sir, okay, we had heard that it's basically a distributed technology. Now you are coming to again centralized concept. Well, let me tell you one thing. Fundamentally, when we say blockchain, the concept was a public blockchain, right? Anybody can join and anybody can leave at the same time. So anytime, right? Anybody can join, anybody can leave at any time. So example like Bitcoin, right? But let me tell you one thing. When you're talking about this education, edutech industry, property registration, then your e-voting, then this supply chain, let me tell you, these are not public blockchains. These are private blockchains, right? So here comes a very fundamental concept. Blockchain can be implemented in two modes, right? Public or private. Public means there is no restriction on who can join and who can leave at any time, right? And there is no provisions around selection of specific people to join. Whereas private blockchain is more a closed system where you can have a person who will own that blockchain, right? You can have a government agency, you can have a company who will own that blockchain, but it will work in a distributed manner, right? Even the owner of the company cannot change, like in the case of centralized system, databases. The owner of the system, like the database administrator, has the authority to change the data, change the records, and change the way it is accessed by individuals or users or customers. But there's a concept like you will have a blockchain, you will own the blockchain, you will be owner of the blockchain, but it will work in a distributed manner, right? So it may have 1,000 nodes or n number of nodes, and all will have the same features, same capabilities, and they will be doing operations like based on your business logic, and nobody can tamper, right? Once the truth has been processed, every node will have the same copy of the ledger, and it will work in a tamper-proof manner, right? So there's a concept of tokens, cryptocurrencies. Mostly when you talk about public blockchains, private blockchain, when we talk about, yes, there's a concept of tokens. We will discuss in a short while when I'll discuss a use case. Merkle tree is a technical concept. As I mentioned, that there is a block can have many transactions. So I told you a transaction data is converted into a code, hash code. So every transaction will be converted into a separate hash code. And then all those separate hash codes would be aggregated to convert into a single hash code. So Merkle tree is basically a hierarchical computation of hash code so that multiple hashes from multiple transactions get converted into a single hash, right? It's like you have a gift box, right? It's already a packed gift, right? But still you are wrapping it around with a gift paper, right? So that it should appear from the outside it's a gift, right? because normal packing would not say it's a gift, it's a product, right? So in Merkle trees, basically, there's a block. In the block, there are transactions. Every transaction has their hashes. So they are like individual products, but you want to wrap it as a single block. So if you want to wrap it as a single block, you have to convert all those hash codes into a single hash code, which can give a identity and address to this whole block. So Merkle tree is a concept of how we compute or aggregate the hashes of separate transactions, individual transactions, and merge them into a single hash code. And peer-to-peer transaction means you can have direct transaction between the parties who are involved in the blockchain. So these are some of the technical concepts. And moving on to the next thing, let me tell you how it is different from ordinary ledger and the systems that we are already having, like centralized systems, where we have databases which are maintaining our data of records, transactions. So blockchain ledgers, user can't change records, so it is inflexible. So you don't have flexibility of changing the records. Let's say you did a transaction, you are transferring some amount, let's say 1 lakh rupees to somebody, but by mistake you added 1 extra zero. So it could be an incident of data diddling, and let's say the transaction gets executed. Now there's no way you can roll back the transaction and change it. So the only way is you can ask the recipient to do a reverse transaction, a new transaction, where they can transfer the balance amount, whatever is the extra amount, right? They can transfer it back. So there's no way you can change the transaction in blockchain ledger. These ledgers possess data integrity. So again, you cannot have tampering. There is no provision of mistakes. So whatever data you provide, it will be processed, provided it matches or it follows the rules and regulations, compliances, rules of the smart contract. So data integrity is there. Once the transaction is processed, it's processed. There is no way it can be tampered and changed. These are decentralized and distributed, yes, so nobody controls it, right? In case of private blockchains, you are just an owner of the blockchain, but you cannot change the data, right? So like you can create new provisions, new rules. Your role would be of a facilitator, right? But you will not be having authority to change the data, right? So you'll be owner of the blockchain, but you cannot change it, even in the private blockchains. But in the ordinary system, centralized system, you have that authority. You can change the data. You can change the way it is accessed by the people who can access that. So in blockchain, there is complete transparency. Everybody has the same visual understanding, operational understanding, and technical understanding of the application. So whatever is happening in the system is accessible to every individual node. It's the same thing in every machine. Whereas in centralized system, you only get very limited access, and you are not even aware of what is happening in the backend. All right. Encryption, everything is encrypted, coded using latest security standards like cryptographic standards like TLS, Transport Security Layer 1.3, whatever are the latest standards. They are used while designing and building the applications, right? So, and of course, upgradations can be done as there are new standards in the market. Whereas in traditional ledgers, there is no encryption, and there is always a chance of misuse of the data. And data handling, users can read and write data, yes, based on the authority, authorization, and the roles in the application. Yes, you can do transactions, you can see your ledger, right, or the transactions that you have done, not others' transactions. You cannot see, right? So in a nutshell, I can say that it's a customizable technology where you can have security, immutability, transparency, everything. And you can design based on your application requirement. Now, talking about its adaptability in India, there are so many states who are using blockchain for healthcare, land registry, vehicle title registration, and public service delivery, like healthcare, agriculture, fertilizer and subsidy schemes, e-governance. Majority of the states are doing it for education and land registry, right? Because this certificates and all tampering of this certifications is a big issue, fraudulent practices are there. Then digital birth certificates, West Bengal is using blockchain for that. So there are so many projects which are being there. And it's just the public sector. I'm talking about the state governments. I'm not talking about the private. Private would be even more, right? There'll be more and more applications. And let me tell you, it's a little old data. So the penetration, the adaptability, and usage would be way more, right? If you go and check the current status, right? So it has a lot of potential. And when you talk about specific use case, like land registry, healthcare, it's basically a private blockchain entity or organization or government agency will own multiple machines across various locations. So they can have a distributed ledger, which is same across all the nodes in the blockchain, right? So there are a lot of applications. Now, one more important question. You understood why it is secure, why it is tamper-proof, but where to use it? I think this is one of the biggest question that chartered accountants, consultants, auditors should have. When to use blockchain? Can we use blockchain everywhere in every application to make it tamper-proof? Let me tell you, it's a big no with capital N, capital O. Why? Because you need to understand the risk associated also, right? One risk is the cost of ownership, right? The cost of ownership of blockchain application, like how much cost it incurs to own a blockchain-based application. It's not just the development cost, it's operational cost also, right? So we need to understand what is the right scenario where blockchain can be used. So here is a very interesting framework released by Niti Aayog under Ministry of IT, Electronics, right? So it's a collaborative effort of many researchers, many like industry leaders, technology leaders, and the result is it's a very interesting step-by-step framework which tells us when to use blockchain and when to not. So you would be thinking that it looks like very complicated framework. Well, let me tell you, it's very easy. Just try to understand as a small kid. A small kid would say, oh, it looks like a game. There are blue boxes, there are yellow boxes. Blue boxes are the decision boxes and yellow boxes are the outcomes, right? Okay, great. So what we have to do is we have to start the game right from the top left corner, right? And it says that you just need to understand a business case. So let's say we pick up business case like e-voting, right? We want to have a e-voting mechanism or maybe like certificate mechanism where institutes like ICAI or maybe any institute wants to release certificates to their members for their accomplishment or completion of their course, right? So they want to preserve the uniqueness. They want to have online validation verification. Normally what happens is there's a big problem with certificate, like in education sector. The traditional practice is there's a university and university has an institute, affiliated institute. Let's say university is in Delhi and there's an institute in say near vicinity NCR. So a student enrolls in a university and studying from an institute. They complete the course, they get a degree. Now to get a degree, they have to go to either the institute or the university. All right. Let's say the student gets a job and he's placed in say Bangalore. Now, one day the company asks, okay, we want to verify and validate your certificate. You need to get certified transcripts from the university. Now that person has to go back to university, get it attested, verified, or maybe somebody's planning to join a course abroad. Then the person needs to get it attested like copies, transcripts for the qualifications he has. So it's a very lengthy, complex process. And let's say you lost your degree, right? You got a 10th certificate, 12th certificate or degree, you lost it. Now, there's no way you can verify yourself that, okay, you have done this certification and that and so on. So don't you think it's a very cumbersome process? Apply for a duplicate copy, then they will go and check the records. And if, let's say you have done your 10th or 12th in, say, let's say 1995 or 98, I'm really doubtful if you can get a duplicate copy. If you can get a duplicate copy, the process would be lengthy, tedious, right? It's hard to get to the database where those records would be there. I don't know whether they have digitized that records or not, right? So it's a serious challenge. But let's assume if this certification and degree process on blockchain, you don't have to move to get your degree. It will be a digital token issued to you through email or wherever, right? And let's say you want to verify, anybody like recruiters or anybody wants to verify, you just simply share that digital token. They will send a verification request, like in the digital signature you have seen. You don't have to really prove yourself that you have digitally signed or you have signed this document, right? So it can be validated by the certifying authority. So same kind of setup can be done, and you can create a application where a digital token has been embedded in the degree, and validation can be done remotely anywhere in time. And you can really remove all the hassles of processing and like stakeholders, and you can make it tamper proof. Nobody can alter the mark sheet, right? Nobody can change it. Nobody can copy the other's mark sheet, and so many things can be achieved. Now let's quickly go through this framework and see how we can validate a particular use case based on this framework. And we will take a small example here about that use case I mentioned about where there's a possible risk of duplicacy of a branded product. Okay, I think that's a very interesting use case because there are so many industries who are worried about this duplication of their products, and that affects their market share and whatnot, their reputation as well. So let's say there's a company who manufactures, let's say, what do you call, apparels maybe, or maybe some shoes, or maybe some other like leather bags, right? So they want to decide whether they should go for a blockchain or not. Okay. So the first point is there a compelling business case to reduce intermediaries? Now, what are intermediaries? Intermediaries are those players who are the middleman who are playing their role, or they are the cycle, right? Let's say there is a transaction cycle. There was a case like property registration. So there is a registrar involved, there's a bank involved, there's a lawyer involved, and duty papers. There is an agency from where you have to get your duty papers, right? And then there's an agency who will verify your identity, like Aadhaar or PAN. So there are so many players who are part of the system, the cycle, transaction cycle. Like you want to purchase a house, right? And the seller wants to sell the house, and there are so many people in between, right? Do you want to reduce these intermediaries or the cost of these intermediaries? Yes, we want, right? Okay, so if yes, then move to the next stage. If no, then you don't need a blockchain, right? If let's say in a bank, let's say in a bank, you are a bank and there is a customer and there is no player in between. Anybody wants to open an account, want to use your banking services? There's no mediator in between. Do you think we should put blockchain here? No, there is no need, right? So we need blockchains where there are multiple parties involved and the process is a little complex. There are so many people involved. We have to rely and we have to trust people for the process, right? And it may delay the transaction process. The processing time may be very high. So that's where blockchain is a very good alternative, right? So if there are multiple, what do you say? Oh, okay. If you want to reduce intermediaries, yes. Second point is, are multiple stakeholders involved? Yes, then go to the next. If there are no other stakeholders except you and your customer, you don't need anybody, right? So you don't need blockchain. Go back to do not use blockchain. So third point is, are you working with digital asset instead of physical assets? If you're involving digital assets like your mark sheet, degree, or maybe let's say you are transferring some, or for that matter, e-vote, right? It's a digital asset. So if it is a digital asset, quickly go to the point number 4. But if it is a physical asset, I think there is one more thing we need to check. And there's the concept of token and tokenomics. Means we must have some mechanism. If there are physical assets, we must have some mechanism to map that physical asset with a digital token or a digital value. For example, let's say I mentioned that there is a branded shoe. Now there should be a mechanism that shoe can be converted into a digital value. And I mentioned that let's put a RFID in the shoe at the manufacturing time, and that RFID has a unique code, numeric code, or a hexadecimal or a alphanumeric code, which you can capture by a scanner, right? Okay. So if we have that mechanism, a physical asset can be converted into a token, digital value, then yes, there is a possibility. But then there is another question, point 3b. Can you couple digital asset with physical asset with permanent and authenticated record of proof? Means there should be a safe mechanism that the digital value which you have mapped with the physical asset should not be tampered or should not be disassociated, right? So that's why I mentioned that during the manufacturing, you will embed the RFID within the shoe. Means if you have to get that token out, so you have to damage that product. So product will lose its identity. So it should be a tamper-proof kind of a mechanism by which you are mapping your physical asset with the digital value. Because if it is not tamper-proof, then what will happen? People will misuse it. They will create copies of all of your tokens, right? And they may misuse it. So you have to ensure that it is authentative record of proof and it's not easily tamperable, right? Or if somebody tampers it, it loses the value. That's the only way you can address that. But if you cannot achieve this, go back. You cannot use blockchain. If you can achieve that, like I mentioned in the case of the shoe and the RFID, yes, let's move to the step 4. So there are two ways, like digital asset or physical asset. In both the scenarios, you can go to the step 4. And in step 4, you have to check, do multiple parties require shared access? It means they will be part of the transaction. Like in the loan application I mentioned, there's a need of regulatory body, like the stamp duty paper body who issues the duty papers, then government representatives, then the registrar who registers or approves the deal, like the selling and purchase deal, whatever happens between seller and buyer. Then there is a bank, right? So there are so many people who will be doing their part. They'll be writing like approval in the transaction. Without their approval or consent, the transaction would not be complete. Same way, the validating authorities, like identity verification validation. Your PAN number, in case you are talking about India, like PAN number is your identity permanent account holder. Then you have Aadhaar, your citizen identity, not exactly citizen identity, but it is used for the same purpose in many transactions, right? So there are so many parties who are supposed to sign or perhaps write during the transaction cycle. So if there are multiple parties involved, then it's a great use case for blockchain. But if there are no multiple parties required, again, you can have a system without blockchain, which is to be faster, efficient, and you don't need a blockchain for that. So step 5, do you require high performance, high transaction rate? So fundamentally, blockchain doesn't support it, but yes, you can customize, you can restructure. As I told you, it's a customizable technology. You have to do a bit of research and restructuring, maybe like you may have to define the number of nodes, you may have to reduce an encryption cycles, or many more factors are there by which you can have a trade-off between performance and security, right? And you can achieve the performance you're looking for. But if there are no constraints of performance, high performance, like in real-time things, then you can have a strong blockchain application without much of an issue, and it'll deliver all the time immutability and security features. Next is, do you intend to store non-transactional data in the blockchain? If you want to store, then you need to restructure your application. But if you are only interested in storing the hashes, the truth, then I think it's a strong case for blockchain, right? You can, if you don't want to store non-transactional data, it's a strong case for blockchain. You can proceed to the step 7. But if you want to store non-transactional data also in the blockchain, then you need to restructure it because it's not recommended, right? because the size of the blockchain will increase, right? And you want to have it as small as possible. So it's better to only store truth, the codes, hash codes in the blockchain. 7th step says, do you want or need to rely on trusted parties or compliance reasons? Okay, if there are trusted parties or regulatory bodies which you want to rely on, then you need to restructure that application. You need to create APIs by which it will be integrated in your blockchain application. But if there is no requirement, then simply go to step number 8. Do you need ability to control functionality? Yes, if you want to ability to control the functionality, not the transaction tampering. So there's a difference. If you have a private blockchain, you may own a blockchain application, but that doesn't mean that you can alter that data or a ledger. But you want to control the functionality, like the rules, the smart contracts, how the transaction would be verified, validated. That would be as per your business needs. So yes, it is a strong case for private blockchain. But if there are no rules or you don't want control, then it's a strong case for public blockchain, like your Bitcoin, or maybe entertainment based blockchain application. Let's say you are making reels and you want your customers would be posting reels on a video platform, and they'll be getting incentives for the views and all, and they want to maintain the ownership. So blockchain can address that they will be owner of their digital content with the use of NFTs, right? And whenever the viewership is there, they'll be getting the royalty against that. So yes, you can build such public platforms, public blockchains, where you can have commercial operations with the features of security and tamper-proof operations. So I hope you got a clarity that not everything should be moved to blockchain, right? So that's a big area of opportunity, right? People would be stuck up, like when to use, when not to use. So that's an opportunity for auditors, chartered accountants, as a consultant, as an auditor, to check whether this is a genuine business case for blockchain or not, right? Before you go into the development process or next phase of implementation, right? And let's say there's a blockchain application, existing blockchain application, you are an auditor. So you can first check whether there was a need of this system or not, right? Because there may be a audit initiated based on the profitability, returns, and all concerns around the blockchain application, right? So you may start with this thing, whether there was a need of this blockchain or not. So there are so many opportunities, and I think this framework is going to be a good tool for you to address those opportunities. So let's move on. Now we'll talk about some use cases, a very interesting use case. Let's say we have a blockchain application where we have identity management or identity records stored in a blockchain application. So what happens is, the moment a human being takes birth in any country, let's say what we'll do is we'll record that transaction and we'll create a birth certificate and we'll register that this person has taken birth on this date, this is the father, this is the mother, and now these father mother will already have some digital identities which are already part of the blockchain ledger, right? So means there are rules, right? So let's say you are raising a birth certificate for a baby. Now the babies, that means there will be a father and mother also, right? So you have to store that data in the blockchain. Okay, so just imagine we'll have a robust system where you can have universal ID for an individual, right? And then that individual, whenever that individual goes and takes the next step, like maybe they do some education qualification, achieve some education qualification, they get some passport, maybe they get PAN certification, some medical records or whatever, all those can be mapped with the digital identity. So you don't need to carry the copy of your digital identity, right? So you don't need to have hard copies and all. And your copy, the identity cannot be misused, right? Why? Because whenever you are availing some services, like in the bank or insurance company, you just have to go there and mention that your ID or some whatever digital token would be issued to you. So they will enter the moment they will enter your token, and they will validate with the blockchain application who you are and whether you are eligible for a loan. They will see your credit rating also, how much insurance cover you should get based on your age and all. So means everything can be synced around your digital identity. And just imagine if this happens, how much assurance would be there, and there will be no misuse of your identity, which is normally possible when you are not having digital identity or a blockchain, right? Anybody can tamper a card, a similar kind of a look and feel, like a duplicate passport. Duplicate passport can be there because it is a physical passport. You can create a copy, similar like copy, right? But if it is a digital passport stored in a blockchain, which is synced with your biometrics, so your face would be scanned and it will automatically send an inquiry in the blockchain who you are, and it will give you a universal ID, which cannot be mapped with any other individual in the world. So that's the kind of spark this universal ID kind of concept can have. And this will be the reality in the future. Sooner or later, you'll see countries adopting this. Maybe one day we'll have a universal identity like this, right? And hopefully most of the people on the earth will be part of that blockchain. Then you'll have a lot of smooth operations, no hassle of challenges, issues, security concerns, hacking and all. Okay, now the next thing is, let's take a quick use case, case study where I'll give you a scenario where blockchain application has to be implemented in a bank, right? And let's see what are the challenges, issues, or what are the steps, what are the factors which we should consider from auditor's perspective or consultant's perspective, that what are the areas we should focus on when we are involved in any such project as a consultant, or we are auditing such project. Okay, so let's take this scenario. XYZ is a leading financial institution, okay, initiated a project to implement a private blockchain application to enhance the efficiency, security, transparency of its internal processes. Okay, so they're thinking of blockchain. The blockchain technology is intended to streamline various banking operations, including transaction settlements, customer identity verification, regulatory compliance. So these are the three primary functionalities we have to focus on alongside banking operations. So banking operations are there, transaction settlement transactions are there, customer identity verification, KYC is there, and then regulatory compliance. 4 things are there. So we have to build blockchain around this. Okay. So this case study focus on audit perspective of private blockchain application deployed by XYZ Bank. Okay, so this is the introduction. So let's take a note on how to plan an audit around this application. Let's say this is an application implemented by a bank. How to audit this, and how to review whether or what are the areas to be reviewed, right? So these are the takeaways which will be learning from this discussion. So step 1 is project initiation and planning, and I'm quite sure that everybody would agree in auditing, the first step is the planning, right? We have to plan the audit. So the objective is to understand the goals and expected outcomes of the private blockchain implementation. And we all know that when we are planning an audit, we understand the system structure first, and then we try to draft our audit objectives. So what are the audit steps here? Review the project documentation and objective, why this blockchain was developed, what are the objectives, assess the alignment of the blockchain application with bank's strategic goals, whether it addressed the business requirements. And what were the business requirement? If you go and check, they want to implement banking operations, they want to include a settlement transaction, customer identity verification, and regulatory compliance. So these are the 4 major objectives they want to achieve. Okay. Finally, the step you have to do in planning is evaluate risk assessment and risk mitigation strategies. So you need to figure out what are the risks associated with these operations, and do they have any controls, or do they have provisions of these controls in their blockchain? So have they considered these concerns when they implemented this blockchain, right? So once you get this data, I think you have a fair bit of understanding of their system, and now you are good to go for the next steps in the auditing. Step 2. Right now, you need to understand the design, because you have got the understanding of the objectives, what you need to review. So try to understand the structure, whether they have these control mechanisms for whatever business rules are there, right? Try to understand the internal aspects, the components of the blockchain. right? So your objective is to examine technical specifications and architecture of private blockchain application. So what we'll do here is we'll try to evaluate the design. So whatever design documentation available is there, we'll see. So one simple factor is how many machines they have used in their blockchain network, number of machines, right? Second, focusing on consensus mechanism. So what is a consensus mechanism? I told you one was like solving the mathematical problem. Second thing was, the second thing could be like proof of work. The one who solves the problem would be given the chance to verify the transaction. So here it could be the same, like proof of work, like solve the problem, or it could be the one who is the oldest node. Because it's a private blockchain, we can define that these are the players who are the old players who are like more trustworthy and all. So you can designate nodes like that, right? So there are different ways how you can select a person to verify, right? It could be based on round robin. Today you are verifying, next day somebody else will be verifying, for the next transaction somebody else. So there are different ways in which you can build consensus mechanism. So you need to check which consensus mechanism they have used. Either it is based on solving mathematical problem, proof of stake, like majority of the stake, the node with majority of the stake is the one who selects, is getting selected for verification, right? So you need to check which strategy they are using for selection of a person for verification. Is it a genuine one, like where everybody gets a chance to verification? Because that enhances the transparency, right? If only one node is getting the chance again and again, so that's not the right strategy when it comes to transparency and uniform visibility. The other aspect that you need to study is the smart contract, where you need to verify whether all the provision rules, like when we are saying about banking operations, so whatever are the rules of the banking operations, let's say account opening process is there. What are the rules when account opening has to be done for a customer? Are they including all the rules like identity proof of the customers? And these would be digital identities, not the physical identities. There will be no photocopy, no certificate copy that you are taking. It will be a digital identity like the PAN number or digital value or maybe Aadhaar number. And it would be validated digitally with the agency, right? So there is no human intervention, no manual verification, no document submission should be there, which may lead to duplicacy, right? So that's the fundamental philosophy behind blockchain, that we are going to eliminate the human factor so that everything is, the trust factor is in the technology, not on the humans, right? So the smart contract will have all these rules and all these verification validations would be done digitally with the help of secured APIs. Data encryption methods, you have to review this. Which algorithm they are using for the hashing, the latest algorithm should be there, right? What are the encryption standards they are using? All those things need to be reviewed, right? And you have to match it with the latest standards or industry benchmarks. Just verify if they have this, okay, then good to go. The second step you have to do is verify that blockchain architecture complies with industry best practices. I mentioned it already. The last thing that you need to check here is assess the scalability and the performance consideration. I mentioned number of nodes, right? Let's say you have a banking application, Pan India, right? It's a big application and there are many branches all over India. Or maybe digital bank is there, right? Online facility is there. So point is, in that case, you need to understand as the user base increases, we need to have more security. Why? Because there's more value now. If more people are there, more customers are there, more accounts are there, more amount of money is there, right, in the bank. So it means there are more chances of getting hacked. So let's say there are 10 banks. Number one bank has 1,000 times the assets in their repository. So the chances of getting hacking attack on that bank is the highest, right? And in comparison to the bank who is having 1,000 times the assets, financial assets. So if you are number one, it means you need to enhance the scale of your network, right? And you need to make it more secure. So scalability is a factor which you need to be reviewed very carefully, because as you increase the number of nodes, the transaction times also gets affected, because now verification, validation, and updation of ledger will take little more time, right? So there's a trade-off, but When you're talking about tamper-proof security, a small delay of say some seconds or maybe a few minutes is good to accept in comparison to $1 billion of assets at stake, right? So if you want to make your network, blockchain network, more secure, you may have to increase the number of nodes, because by increasing number of nodes, what happens? The number 51% increases, right? So if you have 100 nodes, the 51% is 51. If you have 1,000 nodes, then it is 501. So just imagine the amount of effort required to tamper and change records in a system. So that's how you do this step 2 of your assessment. Then step 3 says access control and authentication. Once you have understood the technical architecture and background, now it comes to the user end, how users are interacting. There should be an access control around it. And it's a private blockchain banking application, so users should be authenticated before they access the application. It could be through two-factor authentication, like their user ID number and their OTP, all are digital factors. Or it could be 3-factor also, like their user account, their OTP, user account password, their OTP, and their biometric. So that it's hard to breach identity of anybody or misuse identity of anybody to do any transaction on their behalf, right? So the idea is to ensure only authorized persons are doing the transactions. So you can review the access control policy procedures, whether they are using multi-factor authentication or not, whether segregation of duties are there or not. Like nobody should be able to do transaction on somebody else's behalf, right? So that's what you need to ensure. In step 4, data integrity and consistency. This is the objective. We have to confirm that the data stored on the blockchain is accurate and consistent. So what is required? Here you need to check how the data is getting validated and stored. So the data is getting validated based on consensus mechanism. So verify that it's working fine or not. Second, the hashing, how the data gets hashed should be the latest algorithm. Third, the other aspect is like when you automated your system, when you moved your system to the blockchain application, whether you have migrated all the data on the blockchain or not, because that may lead to inconsistency in the account balance and many other things. So you need to check the data integrity by covering the complete data, right from the origin, from the very first account since the bank has started operations. So all the legacy data needs to be migrated to the blockchain before you actually start the blockchain. So you need to check whether all that background data has also been migrated to the blockchain in a tamper-proof way or not. And assess the error detection and control mechanism in place, like whatever detective controls and corrective controls are there in place, right, need to be reviewed, right? Perhaps let me tell you one thing. When you're talking about tamper-proof system, but let me tell you once tampering or attempts, there would be attempts of tampering and hacking. So what you have to do is find such incidents and make a log of it, so that you so that you can strengthen your systems in the future, right?
There is some
Hello. Hello.
Yes, sir. Your video has stopped.
Okay.
Yeah, please go.
Is it fine now?
Breakage. Yeah, please go ahead.
Right. So yeah, so you need to have some mechanism in place by which you can check whether all the data has been migrated, so that you have smooth operation, and there may be chances that somebody is trying to tamper the data, or there is an attempt of hacking. So you can create a parallel mechanism where they will record such incidents and attempts, so that you can learn the lesson and can upgrade the system in the near future, right? So that's the things that you have to do in terms of data integrity and consistency. So we know our system is tamper-proof, but there will be attempts. So we need to record those data as well, like how attempts of tampering are being made, what was the frequency, what was the mechanism, so that we can take into consideration those factors in the future upgradations of the technology. Regulatory compliance. So whatever regulatory compliances are there related to KYC, AML, that anti-money laundering and other provisions, all these need to be incorporated in the smart contract, because a smart contract is the basis on the basis of which these transactions. Regulatory compliance is another factor which we should review, and we must consider that all the transactions are abiding to these smart contract is covering these things. Security encryption, that should be latest and should be as per industry standards. And we must, of course, I mentioned there should be incident response mechanism. There should be business continuity provision. Like if somebody is trying to attempt and hack a machine or tamper our machine, one of our existing nodes, so we must have continuity planning, like that machine should be switched off from the network immediately so that rest of the network can work seamlessly without any issues. And all those incidents should be recorded. Monitoring and reporting, it's fundamental to any SIN or not, right? So we have to have regular monitoring in place so that we can measure our performance, we can measure our security, we can measure our returns from the application. So KPI, KRAs, whatever are there. So you need to define your monitoring tools around your blockchain application and make sure they are there and they are meeting the needs of the stakeholders, right? Smart contract is the most sensitive component. That's why I highlighted it exclusive rules and provisions, right? And you must consider all critical verification in terms of user identity and before it is deployed, right? And whenever there is a provision of change, it should be a very regulated or controlled mechanism. I hope you all understand there's a concept called change management. So let's say there's a change in regulations. So whenever there's a change in regulation, you are supposed to change your smart contract, right? So how the smart contract is changed? This is a big risk if you are not having a robust mechanism to facilitate change in smart contract. So you need to have a well-defined, systematic, automated mechanism of facilitating change in smart contract. There should be people responsible, like senior authorities in the regulatory body, the bank, then other agencies like who will be verifying the identity of the senior players. So all those should sync, and there should be a proper process of change implementation. Finally, ongoing monitoring and improvement. You should keep on improvising and improve and upgrade your application as the need arises. As mentioned by Anju ma'am, there are chances that quantum computing would be in practice soon, right? At commercial level, in a bigger way, right? Global user base could be there for quantum users. And if hackers have access to such computing facilities, they may try and attempt hacking blockchain applications. So in that case, what we need to do is we need to upgrade the hardware of our blockchain machines, right? So we'll upgrade our blockchain machines hardware as well as the software, the smart contract, the cryptographic hash, cryptographic algorithm. So as the computers evolve, we'll evolve our application. But we must say that the fundamental logic which is being used to build a blockchain application is robust, right? So as and when there is a change in our enhancement in computational power, we just need to upgrade our softwares, and we'll still be able to preserve the protection and safeguardance of our digital assets and the data, right? And we'll be able to achieve our tamper-proof systems, right? So that's how a blockchain works. I gave you a small use case on how auditing can be designed around it and can be done around it. And I highlighted some of the aspects about how blockchain work. I mentioned about a use case, right? And I give you a quick demo on how the hash function works and how there are multiple nodes working in tandem on the top of smart contracts, giving you a tamper-proof environment, and you can have anytime access to the network and you can do the transactions. right? There is a public-private blockchain mechanism. So if you are looking for owning a blockchain and deliver assurance in your organization or a particular process that you handle, I think private blockchain is the right use case. But yes, you need to check the feasibility, whether it really is a genuine business case or not. It covers multiple stakeholder right operations, and you want to own it, right? So then it's a private blockchain use case. I gave you some interesting use cases, and then we discuss this case study. I hope I've given you a fair bit of understanding about it. Now I'm open for all the questions that you have.
I want to first of all thank you for the excellent deliberation. And I could easily gauge that the love for the subject matter for you is immense. And the way you explained to us was so interesting.
Thank you.
Before I begin with the questions, there's a compliment for you from Shipra. She says that the session is really informative and helpful. So moving on to the questions. Allow me a moment.
Yeah.
Hitesh wants to know, how do we record the blockchain transactions and what evidences should be looked into as an auditor?
Okay.
So I believe the slide explained what evidences are to be looked, and the transactions are recorded in the hash format.
Okay, I told you, let's say there's a transaction. I gave a use case. Let's say the shoe has been manufactured. So what we have to record is the timestamp when it has been manufactured, right? And then the identity of the shoe, like the digital token, right? And now this data has to be stored in the blockchain. Now, there are two things. Either we want to store the data along with the hash, because transactional data is one thing. Truth is another thing. Truth is what? The hash value that we get out of this data. Now we have to decide whether we want to store both things in the blockchain application or only the truth, right? Now, if we want to store both the things in the blockchain, it will increase the size of the blockchain as the transaction increases, okay? There's an alternative. The alternative is we'll only store the hash. How we'll do it? We'll have the transactional data and it will have a unique ID, say 1, okay? First shoe, ID 1, second shoe, ID 2, and there is no repetition. So now this ID 1 and the hash code of the transactional data will get stored in the blockchain, which is a very small piece of data. So it doesn't matter if you have billions and billions and trillions and whatever, infinite transaction, even then it's not going to be a big size blockchain, right? So one thing is you need to decide on whether you want to store only transactional data, means you want to store transactional data also, or only the hash value, one thing. Once this is done, from perspective of auditor, you want to you raise the question how to verify and validate it. Let me tell you, in blockchain, as an auditor, you're not supposed to check the integrity of the data. The blockchain fundamentally says that there is no tampering, so there is no point checking the transaction data. You, as an auditor, if you're auditing a blockchain application, you don't have to check the data. That's not part of the audit objective. You have to check only the smart contract, right? And you just have to check the ledger is maintained by 51% of the people, right? Right. How it can be done? You just do one thing. You just do a new transaction, right? And get the latest ledger. That is a ledger which is being accepted by majority. Or let's say you just log into one machine, blockchain machine, as an auditor. So whatever ledger is there in the machine is the final ledger. And that ledger is itself a repository of the truth. You don't have to check whether the transactions are valid or not. All transactions are valid, correct. There is no point, nobody can change it, right? The only thing you need to get is get the summary printout of the transaction, right? For the sake of your audit report, right? So what you have to do is there will be a module available in the blockchain application, audit module. Go and generate the summary. It will create a 1-2 page summary, which you have to attach in your audit report, right? Right. And then beside that, your real role is to check the smart contract, whether all provision rules are there in it. Your role is to test the access controls, right? So that's the thing that you have to check as an auditor. So that is access controls, smart contract, and if it is having non-transactional data also in the blockchain, or maybe non-transactional data or a transactional data is in a separate system, like a database, then you may have to check that data, right? But the blockchain is taking care of ledger, so you don't have to validate every transaction or a transaction consistency.
All right.
Any other question?
A lot of them. You
Yeah,
also
sure.
want to say that this technology is very useful in the gaming due to its immutability and security. So, what is the reliable source to determine the gain or loss?
Gain or loss in terms of
Gaming industry.
gaming industry. Okay.
Yeah.
Well, let me tell you, when it comes to gaming industry, I can relate it with one example. Let's say, like this, which is like this bidding and this gambling and all these agencies are there. These gaming applications are there. So yes, there is a lot of scope, because you know what happens most of the time. Let's say you have an online poker game, right? So you're playing game, and normally what happens in gambling is based on a concept of probability, right? So let's say there's a person who's playing the game, right? There's a lot of statistics and probability involved in gaming, especially the gambling things, right? And the point is, the systems are designed in a way that more the people play, more the benefit would be there with the agency who owns the application, the casinos, or maybe the other players. Now there are chances that they may design it in a way that helps them more, right? Which is a risk, right? So I think it's a valid question raised. If we put that application on blockchain, there'll be more transparency, right? And there'll be a even what do you say, possibilities, and there'll be more realistic probability and chances of winning the games, right? So I think blockchain is a very good solution for online gaming, especially this gambling and all bidding and all those things, where you want to have transparency. Otherwise, it's totally a fraud. It's not a genuine application, right? So I think, yes, there's a huge opportunity in gaming industry, especially this bidding and online games, which are based on gambling and probability.
Jerome wants to know, is blockchain technology used in banks, and can it be used for total accounting or just in CBS it's used?
Great. I think it's a very interesting question, and I must take you to the slide here. I told you, let's say, are multiple stakeholders involved? Is there a compelling business use case to reduce intermediaries? When it comes to banking operation, basic banking operation, like there's a bank and there is a customer, and they have an account and they want to just do transactions. Do you think we need a blockchain here? There is no intermediator, right? So banks will not use blockchain for this. Why? Because their existing system is more efficient, more faster, more effective as compared to the alternative blockchain. And they already have heavily invested in their CBS system. Now you will say, then what is the provision? Why banks are shouting so much that blockchain is going to be a game changer for them? Well, it's about the new aspect. I think Anjum also introduced CBDC, right? Right. So digital currencies are being issued by many governments. They are approving the concept of digital currencies, right? Means it would be the mapping of their fiat currency in digital format, right? So it means, let's say you want to facilitate quick transaction, business transactions among big players or like companies, right? Normally that process is cumbersome. There are multiple intermediators involved, right? There are agencies involved who are doing some intermediary services, but the whole process takes a lot of time because there is approval required. It's high volume transactions. So in those scenarios, yes, you will have a blockchain system where CBDC kind of currency substitution would be there, and there'll be smart contract which will be curtailing, which will reduce the turnaround time of the complete cycle, which takes 1, 2, 3 days. Normally would be done in few minutes. All right. The other aspect is KYC. Banks use blockchain for KYC rather than their account opening and this debit or credit transactions, right? So we need to understand from our business requirement where blockchain really fits in. because you need to invest and you need to have operational cost also, right? There will be operational cost associated with the blockchain as well. So that needs to be considered, right? So yes, there are use cases for banks, but not this fundamental banking operation. No, I don't think they'll be switching so quickly because they already have a very strong system, fast, and you already have so much of user base around it. So you don't want to change that system because that's a big change that may disrupt things, right? That's a
Puneet,
big risk.
I'm sorry, please continue.
Yeah, that's a big risk. So they should evaluate in what use cases blockchain is delivering them more return, right? So that's how you can decide upon that. Yes, there are use cases for banks.
Moving on to the next question from Puneet. He wants to know that some jurisdictions like Brazil have implemented blockchain for VAT and income tax. Are there any applications currently implemented in India?
I think to answer this question, I'll share a URL with you, that is blockchain.nic.in. Go and check it. It's basically a government website. They talk about everything. Let me just show you that website. I think you will get the excellent answer for this query, and you will see a government is really taking all steps which are to be taken to really address the need of our country's development, right? To make systems more efficient, more robust.
To add to that, till the time you open the screen, there's a related question from Ramananthan. He wants to know whether Aadhaar has been built on this technology.
No. Aadhaar was built way back when nobody was talking even about blockchain. So I think this will take you to another question. Then how we'll be moving on with the blockchain thing when we already have systems like PAN and Aadhaar? So that brings an interesting question. So for that matter, what will happen is we need to build a blockchain framework which will be integrating Aadhaar in it, right, as an independent module. So Aadhaar would be part of the blockchain system later on, right? We cannot ignore Aadhaar as of now, and of course that's a need. So there are policies going on, there is a development going on, right? So you will be seeing that the system will be integrating Aadhaar application, even Aadhaar, even PAN, all these things would be integrated. Yeah, so the application, this is a website, blockchain.gov.in. So let me share my screen so that I can show you whatever is happening in this area and what applications are there in practice. I hope it is visible.
Yes, it is.
Yeah. So you can see this live chains. You can click here. There is a project certificate chain, document chain, property chain, logistic chain. These are the 4 ongoing applications, right? Which you can go and check. You click on any one, it will show you the details about that. What is certificate chain? Who all are using right now? Okay, so you can go and check further details about it. So the website is blockchain.gov.in. Okay, then you have document chain, property chain, logistic chain, and then there are a lot of material available related to these products. And you can go and check various platform features if you want to understand blockchain further. The technical aspects, features, and everything is available. So we must appreciate the way government is putting efforts, right, in passing on the right content, right information, and right services to the stakeholders by the help of these technologies, right? It's not that they are building the system, they are propagating the right content and information to the citizens as well. I hope this will address your query, and I think it's enough information available. It will give you a lot of things. You'll be able to observe what's stored in the future. We are going to get better day by day, so there will be a lot of opportunities for consultancy and auditing in this domain. Can we have next question?
Sure. Jerome wants to know if changes cannot be made or audit trail is available, will it discourage the banking sector to go for blockchain technology? Because as it is, they have a robust system wherein they are able to change the NPA position.
So that's what I'm saying. So they need to check where blockchain fits in, right? So you need to see if it really goes in sync with your business objectives. If you want a provision to make a change or update, blockchain is not a technology for you, right? So if you want that provision of change updation, so blockchain is not the right technology. So you have to go back to your centralized system where you have a database in the backend with the centralized control authority to update.
And
Next question.
To add to that query, is data leakage possible in this technology? Or can the data be favorable conditions?
I told you, whatever ledger is there, it only has summary, right? And summary cannot be revised. Means you cannot means you cannot recover data from the summary because it is irreversible, right? So it's a small piece of code and it cannot give you any data. You try any technique because mathematically it has been designed in a way. It's like you have sugar cane, you have fruits with you, and you convert that fruits into juice. Now from that juice, you cannot convert them back to fruit, right? There's no technology. It's the same concept, right? It's only one-way encryption. You cannot get the data back from that code. And that's the reason nobody knows who created Bitcoin. Nobody knows who owns how much Bitcoins, right? And you cannot really get the details of the transaction from the hashes which are available in public domain. You can go and check the hash of every node, right, in the Bitcoin wallets, but you cannot see what transaction and is there. And all you can get is this public address has done a transaction with this public address and nothing beyond that.
One last query is from Ramananthan is that is a digital rupee issued by RBI based on blockchain?
Yeah, I think it is in sync with the concept of CBDC, and there's a lot of work happening. They have announced the project, right? And there is a lot of work has to be done in successful implementation and integration with use cases like trade finance or maybe C2C or B2B trade or commercial transactions and all. So yes, soon there'll be a lot of things, and you will see that kind of a thing listed here in live chains, right? So soon you'll be seeing those kind of chains also here, similar to certificate chain, document chain, property chain, logistic chain, right? These kind of banking chain, maybe like by RBI would be there soon, right? Where they will be making it uniform and user friendly, like a industry friendly mechanism of trade for facilitating trade finance. And maybe I've heard many banks are already doing this with the other banks through blockchain, like bank to bank settlements and transactions. They are happening in blockchain.
Okay. This brings us to the end of the session. We are done with the questions for the day. And I really want to thank you from the bottom of my heart for your valuable time and the useful insights, Dr. Vinay.
Thank you. Thank you, Priya, for your support. And thank you, Anju ma'am, for initiating the session. And yes, our leadership, like Nanda sir rightly mentioned, data is the most valuable asset, and we are supposed to preserve it. We are supposed to process it in a very safe and secure manner. And that's why blockchain is there. And I hope I have addressed most of the concepts. Even still, if you have any queries, questions, I'm available on LinkedIn. You can search me and we can connect. And I'm happy to help you out. Thank you, Priya, for your time. Thank you. Certainly. Have a great day. Thank you all. Bye-bye.
Yeah, bye-bye. That's a wrap up for everyone. Have a great weekend ahead. Bye all.
Thank you.